Hello, class. We're going to take notes on energy today. And this is not the type of notes you might be thinking. It's nothing to do with kinetic or potential energy or electricity or anything like that. This is energy from the standpoint of biology. So in other words, how it's a part of the ecosystem and how it's cycled through. Let's see, how did I word this? Sorry, hang on. Okay. This output is going to be called find examples. And that's going to be on page 62. Go ahead and take a moment to write that down. And that is the last thing that's going in this notebook. Wow, good times. Okay, flip with me to page 61. That's going to be energy and ecosystems notes. So we're going to talk about energy and how it flows through an ecosystem. And remember, ecosystem is all the abiotic and biotic, so living and non-living components of an area. So energy flows through an ecosystem and actually flows in one direction. I don't mean the band. And this, obviously, you've probably heard energy flows in one direction in an ecosystem, but really it's a cycle, right? It comes back eventually. Starts with, goes from the sun is where the energy originally comes from in an ecosystem, usually, or it sometimes will come from some sort of chemical compound, like in the ocean, like thermal vents can provide the energy that's needed for an ecosystem. So it's either from the sun or from chemical compounds. Any ecosystem that you are super familiar with is probably going to start with the sun. That's just, most of them do. And then it's going to go, so it's going to flow in one direction from the sun or chemical compounds. And I don't know why I closed parentheses. Sorry about that. So start with the sun. It's going to go to producers, which are things like plants that produce their own food using the sun's energy or chemical compounds, to consumers, those that need to consume the producers in order to get the energy that they consumed from the sun. So that's just kind of how it flows from the sun to producers to consumers. And obviously there's various levels of producers and consumers, which we'll talk a little bit about. Okay, we're going to break this down into 3 components. So first one you've probably heard of, it's called a food chain. And that is an illustrated way that to show how matter and energy move through an ecosystem. Okay, that one is basic. It's just looking at one form of energy passing. So I could say sun provides energy and the grass grows, and that's a producer. Also called an autotroph. In other words, it's autotroph. magically makes its own food from the sun. So a producer and autotroph. Let's say then the grasshopper eats the grass. And that's going to be what's called a primary consumer. Primary meaning like the first thing to consume the producer. And that's a heterotroph. All consumers are heterotrophs. They have to consume in order to have energy. These make their own, these consume to have energy, grasshopper. And then from there, let's say there's a shrew that comes along and eats the grasshopper. You guessed it, that's a secondary consumer. Also heterotroph. And then let's say we keep going. Last thing, let's say an owl comes along and eats the shrew. That's called tertiary, which is like the third tier, tertiary consumer or a heterotroph. That owl, that owl is usually it's going to be the last in that chain, but in theory, that owl eventually will die, and not even in theory, reality, an owl will eventually die, and technically there would be, and I'm going to put a star, a decomposer who would come along and actually break down and decompose the owl. And once that is broken down, the whole process starts again because the nutrients are provided to the producer along with the sun to grow the grass, and then the cycle continues. Okay, so in theory, that decomposer starts the cycle again, right? And that's how energy moves. So these arrows just show the flow of energy. It's not what eats what. The grass doesn't eat the grasshopper. The grass takes the energy from the sun that it received. And then when the grasshopper eats the grass, that energy goes in this direction. So the food chain shows the flow of energy. So we could technically draw an arrow here because the energy would go to the decomposer. And that decomposer, when it breaks that down, goes into the nutrients of the soil, which causes this whole cycle to start again. So this is a chain. Chains go in one direction. Okay. So that's food chain. Food web. This shows all possible feeding relationships in a community. So we know that there's not only shrews that eat grasshoppers. There's not only grasshoppers that eat grass. We could, in theory, have a whole bunch of all the different food chains and combine them and actually lay that out to show all the connections between them. I'm going to have you look this up on your own as far as what it looks like. So you can find examples and that'll be part of your output. But the concept is that it's all the food chains showing all the different directions that energy could flow. It basically links all food webs. And it still has the arrows showing the flow of energy, not what eats what. That's important. Okay, so that was food web. The last way that we show energy moving in an ecosystem is through what's called an energy pyramid. An energy pyramid is a diagram in the shape of a pyramid, shocking, that shows the not just the flow of energy, but the amounts of energy. At each, what's called trophic level. And trophic level goes back to the tertiary consumer, secondary consumer, primary, and producer, etc. So if I were to draw out, you could fill this in with any, oops, pencil broke, with any food chain. You could lay this out the same way. Like I could take this food chain from up here and turn it into an energy pyramid. But it's a brilliant shape for this because it shows that the energy level that's passed actually gets smaller. So the first level that gets its energy directly from the sun gets tons of energy. So the producers have all this great energy. When they are consumed by primary consumers, they only pass 10% of their energy to that consumer. And that pattern continues. So if we have our secondary level, I'm going to abbreviate second and third, and technically we could go fourth quaternary level. There are some ecosystems, like especially ocean ecosystems, which have like sharks that will even eat tertiary consumers. But it doesn't actually matter which level you're looking at. Only 10% of that is passed along, of that same amount of energy from the sun. So that's why the organisms get bigger, 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 because they need to be bigger to pass on more energy. And also the population amounts, it's interesting. The population amount goes from large, so there's tons of producers, so many plants, but there's not as much of each of the consumer levels. And the ecosystem that has the smallest number is going to be the fourth. Imagine if there were the same number of sharks as there are pieces of algae in the ocean. I mean, we would never get in there. So it goes from largest population to small. That's population growth. So we could lay out any food chain on this pyramid and it would still show you that there's only 10% energy going up. And I could actually lay it out, and by calorie, I could say these producers hold 10,000 kilocalories. This is 1,110, etc. Goes up from there. So down here, there's technically the sun, remember, because the sun, or chemical compounds, but the sun is where that energy comes from originally, and it works its way up. That's where the energy is from. We can also put decomposers on here to show that, you know, all of this gets broken down eventually, and those decomposers turn that soil into nutrients again, which, like a worm or whatever, and create the producers from the sun, and using the sun to start the whole thing over again. So what else do I need to tell you? Oh, just make a note that that 10% thing is called the 10% rule. And it's just the idea that 10% of energy is transferred from each thing that eats each thing, only 10%. Okay. I don't know how well I worded that. Sorry. Okay, so you've got these three different things: the food chain, the food web, and the energy pyramid. What I want you to do is on the output, I want you to go on Google, or maybe you already have these facts in your head. I want you to find some examples of food chains, write them out or draw them out. Find a food web. I would say try to find at least 3 examples of food chains. You only really need 1 example of a food web and 1 example of an energy pyramid, but find a couple of food chains, find a food web, write it out, and find an energy pyramid and write it out. And just give us some visuals. The more visual, the better. Okay, that's your output. That's your last output. That's so crazy. Anyway, all right. See you later.